this lesson I'll do a brief practical just to demonstrate how my stack machine works. So I'll go to the top, the main circuit which I showed you at the beginning. So this is how it works. First of all, I'll jump to address 0. That is, I'll have to first of all reset it. Then I jump to address 0. The address is already set at 0, so I put my pointer on. That is to jump to that address. I clock it. Then this is the equation I want to solve here. 22 times 2 plus 10 divided by 2 minus 5 times 4. The actual answer is 29. 29 is the answer. But this is how I'm going to input the data first. First of all, put 22. Since my inputs are all 16-bit, so first of all, 22 is 22. 10110. Then multiplication. Now from the ALU, this is the ALU here. And let me show you how I got all of them. So the first one is 0. The 0 doesn't do anything. 1 is or, 0 is 2, and is 3. Shift left, shift right, 4 and 5. Addition is 6. Subtraction is 7. Multiplication is 8. Division is 10. So these are the values I'll be using to represent each and every one of these arithmetic operations. So, and if you're going to represent any of them, the multiplication, addition, division, subtraction, all of them, you add the 1 at the beginning. I already explained it earlier. This 1 in all of them. This is the 1 here. This is the 1 here. This is the 1 here. So this is 22. Sorry, let me do it well. 22 multiplied by 2 plus 6 I told you earlier, plus 10 divided. Division is 10 also, but now see the difference. The division has a 1, but the normal 10 doesn't have a 1 at the beginning. Divided by 2 minus 5 multiplied by 4. So I ended it with another sign, which is 0. And remember, the 0 returns the value, and that is why when I was talking about the control, let me show you the control here. At the lowest button of the control, we checked when position A is equal to 1, whereas we checked others to be 0. So you have to return the value back to the stack. As in, position B, the one that stores the operation, is going to be at 0. You are going to check it when, see, position B was checked when it's less than 1, that is when it's 0. The in position, that is for your input, was checked when it is equal to 0. But your position A was checked when it's equal to 1, because you have to return it. It's after you've returned it, position A will now go back to 1, and you return it using this 0. The 0 doesn't do anything on the input, it just returns it back. So that is why I added this last sign here. So you always have to end it with this, so something like this. You always have to end with 1 0 0 0 0. So the 1 0 0 0 is acting as a return. It returns it back to the stack so that you can get an output at here, the peak. Because peak, well, when you go through the lesson, I explained peak as the topmost of the stack, and that stack is stack A. So after it has returned it, we can be able to check and see what is on top of the stack. So this is what I'm going to input right away into the stack. Let me clear the signs. So I'll first of all start with the list one, because remember, a stack is last in first out, and what the first thing I want to be out is 22. So that will be the last thing I will put, so so that if I put it last, it will be the first to come out. So I'm going to start opposite ways, starting from the bottom here, 100. So we are expecting to get this answer. This is 29 here. So let me just show the demonstration. So this is 100. Then I'll go. I think I'll just pause this video, but let me just show you how I do one of the inputs. So I now set it to 100. Everything is 00. It is no longer in jump. Then I turn my push on. Then I push it first. I've pushed it. Then I check for the second one. The next one is 100. That is for 4. I'll just pause this video so I'll be able to input everything at once. So you just see how I did the solution. So at this point, I've successfully inputted everything. So you can see from here, this is my last input here, and the last address is 1100, and that is 12. So if you go to the inputs, you can see this 1 2 3 4 5 6 7 8 9 10 11 12. So I've successfully loaded all these things inside. I'm expecting this answer, which is equal to 29. So at this point, I'm no longer using my normal clock. I'm using the auto clock. Let me start the clocking process. But for now, let me place it on reset. Then let me start it enabled. So I think everything is fine now. So let me remove the reset, and then you'll be able to see it has already selected the computation. So at the end of the computation, so I had to start at first. What I'm saying is, at the end of the computation, the empty signal is going to turn on. So I turn on my pointer first, sorry, to point it to that as address 12. Turn the point off, turn off my reset. So watch. What I would, okay, now this is the final answer, which is equal to this. So another thing I can as well do is to, because I'm using a low frequency clock, so let me increase the clock frequency. This is still in kilohertz though. So I will reset it, then I'll point it back to this address 12. Then I think that's pointed. Then so this is it. So this is just a simple demonstration of how this clock works, how this start calculator works. So with this, I come to the end of this tutorial. Please like, share and subscribe for more tutorials. This is my motivation. I'll be coming up with a new processor design tutorial next week. The value code for this stack calculator can be found on my website, projectfpga.com. so the output is working. So this verifies the code. I normally don't do test benches, so I use Logisim as my test bench for checking and error corrections. So thank you so much, and